Dear students, today we are going to start with the topic by which you all are familiar with. The name of the topic is electricity. In your junior grade, you have already learned about this topic called electricity and various phenomena associated with it. Like that, how does lightning take place during a rainy season, or why we generally advise to not to touch the electric switches with wet hands, and many other. In this chapter, we will going to learn that how does all these things take place and what are the exact phenomena behind that. So let's start with this chapter, electricity. So before we start with the chapter electricity, we have to understand that what do we mean by the term electricity. Electricity, in simple words, you can say the study of electric charge is known as electricity. The study of this electric charge. So then the question which arises over here is that what do we mean by the term electric charge? Electric charge is nothing, or you can say it is the property associated with matter due to which it produces and experiences electric and magnetic effect. It is just the property which is associated with matter. Any substance you pick, every substance which is, you can say it's a table or a chair or anything which is around you. So all the things are made up of matter. So it is a property which is associated with matter due to which it produces and experiences electric and magnetic effect is known to be as electric charge. So this term electricity is categorized into two parts. It is categorized into two parts. One is known as the static electricity. Static electricity. Static electricity is also known to be as frictional electricity. Frictional electricity. And the second one is the dynamic electricity. Dynamic electricity is also known to be as current electricity. Current electricity. So now we are going to understand these both terms in detail, that what do we mean by static electricity and what do we mean by dynamic electricity. Now we are going to understand these two categories into detail. So the first one is the static electricity. The word static over here, it taken from the word stationary. Stationary. It also stands for the state of rest. Okay. So in static electricity, we will going to deal with the charges at rest and the phenomena associated with them. Or you can, in simple words, you can say the study of electric charges which are at the position of rest and the phenomena associated with them is known to be a static electricity. Okay. So now we are going to learn about what is current electricity. So in this we will first of all going to understand the meaning of the word current over here. Current. So we generally say that near the bank of the river the water current is very high, or we generally install windmills at the places where the wind currents are very high. So what is current? In simple word, current is nothing but it represents the state of motion of anything, motion or flow of anything. Okay. So what do we mean by current electricity? In current electricity, or you can say current electricity basically deals with the charges in motion and phenomena associated with them. So we will going to study both this category of electricity in detail. Okay, let's start with first static electricity. Now we are going to learn about static electricity in detail. So most of the substances which are around us releases static electricity when they are rubbed against each other. Okay, it's the very first point about the static electricity. Insulators are the ideal source, basically are the ideal source for producing this static electricity. We will study that how they are the ideal source. Okay, and the third point says the electricity developed on the surface of insulating bodies when they are rubbed against each other is known to be as frictional electricity or static electricity. So due to this rubbing between two bodies, whether it's insulator or something else, the force of friction came into action and there is a transfer of charge which take place, and that's why it also known to be as frictional electricity. So we will see that how does it happen. Let's suppose now we will discuss about the source of static electricity, or you can say how does the static electricity works. Let's suppose we have two bodies over here, body A and body B. Okay, body A over here is made up of glass. Okay, and body B over here is made up of rubber. So we try to rub these two bodies with each other. Okay, we rubbed these two bodies with each other. So what will happen? The body A, which is glass, it is in excess of electron, have excess of electrons. Okay, and this body B, it is electron deficient. So when we rub these two bodies together, this glass will tend to lose electron as it has excess of electrons, and the body B, which is made up of rubber, is electron deficient. So whatsoever electrons this body A has in excess, these electrons will be transferred to body B, and body B will take or absorb those electrons. Thus, due to this action, the body A will become positively charged as it loses electron, whereas body B will become negatively charged as it gain electron. It loses electron and this one gain electron, become negatively charged, and thus due to this action there is a force of attraction between body A and body B due to the opposite charges, or you can say due to the unlike charges between both of them. So this force of attraction between two bodies when they are rubbed with each other is known to be as static electricity. So let's say what it says over here. When two substances are rubbed together, then some electrons are removed from the surface of one substance and transferred to another one. Okay, so this is how we see that, how does this transfer take place over here? The substance which gain electron become negatively charged. As we see, body B, which is made up of rubber over here, gains electron and become negatively charged, and the one which loses electron become positively charged. Body A, which is made up of glass, loses electron over here and become positively charged, and this property of excess and deficiency of electron, this is a symbol for electron, makes the substance or you can say the body substance positive or negative. Now we are going to discuss about the properties of electric charge. So the first property of electric charge says that electric charge is a scalar quantity. It can be of two types, positive or negative. So I hope you are aware about the terms scalar and vector. Scalar are basically the terms which are associated with only magnitude, whereas vector are the terms which are associated with magnitude plus direction. Okay, magnitude plus direction. So let's say for scalar, let's say if I say that 25 kilometers, over here 25 kilometers is the magnitude, whereas if I say 25 kilometers east, I have associated the direction with it, which is east. So now it becomes a vector quantity. So that's the difference between scalar and vector. So the first point says over here is that electric charge is a scalar quantity. Let's see over here. Let's suppose a 2 coulomb of charge is coming from here. Okay, a 3 coulomb of charge is coming from here. So how much will we go over here? 2 plus 3, 5 coulomb. Okay. Let's suppose if I change the direction over here, if I make it like this and I just rub this and make this like this one. So 2 coulomb is coming from here, 5 coulomb is coming from here. So how much will we go over here? 7 coulombs, 2 plus 5, 7. So in this case of electric charge, the direction matters, but we are still saying that it's a scalar quantity. Okay, so just for the factual thing, just remember that electric charge is a scalar quantity. In your higher grades, you will get to know that why it's called scalar. Actually, it's a scalar one, but if you talk in more scientific way, it's known to be a tensor quantity. In higher grades, you will going to learn about this, but for the time being, you just understand that electric charge is a scalar quantity and it can be of two types, positive or negative. It's a fact. So now we will come to the second point. The second point over here says that like charges repel each other, while unlike charges attract each other. Let's see this property with the help of an example over here. Let's suppose we have a surface over here. Let's call this surface as A, okay? And we just tie up one string over here with this surface. And with this string we suspend one substance which is made up of rubber, okay? Which is made up of rubber, okay? And we have one more substance over here which is made up of glass. And we rub these two substances with each other, okay? So after rubbing, what will happen? The frictional electricity came into picture. The positive charge will develop on the surface of glass, whereas the negative charge will develop on the surface of this rubber substance. And when we try to bring this substance, or you can say this glass rod, near to this rubber substance, there is a force of attraction between both of them. So by this thing we clearly see over here that like charges repel each other and unlike charges attract each other. So these two are the unlike charges over here. So they will try to repel each other, or they will try to attract each other over here. One is positive and another one is negative. So there is a force of attraction between both of them, okay? Let's take one more example over here. Let's say we have a surface B over here, okay? And again we tied up a string over here, and with this string we just suspend one substance which is made up of rubber, okay? Which is made up of rubber, okay? Let's take one more substance over here which is also made up of rubber, and we rub both of them. So what will happen? Both are electron deficient. So static electricity will came into action, but this time both will have negative charges on themselves. And when we try to bring this rubber rod, or you can say rubber substance, near to this one, both have likely charges, both are negative. So they tend to repel each other. So you will see in this case the glass rod will move in this direction. This rubber substance will move in this direction as we bring glass rod near to this. There is a force of attraction between them, and when we bring this rubber substance, or you can say the rubber rod, near to this one, it will move in opposite direction, as there is a force of repulsion between both of them, okay? So now we will talk about the third property of electric charge, which is known as the additivity of charges. So what this property says, the total charge of the body is the algebraic sum of all the individual charges present on it, each being taken with its proper sign. This property of charge is known to be as additivity of charge. So by the very first property we came to know over here is that electric charge is a scalar quantity. So it's talking about the algebraic sum of all the individual charges present on one body, okay? So by the scalar law of addition, we know that the charges can be added as Q is the charge. So we have Q1 plus Q2 plus Q3. We add charges in this fashion by the scalar addition, so on up till Qn, the number of charges we have, okay? Let's suppose we have one body over here. 2 coulomb of charge is coming from here. 3 coulomb of charge is coming from here, 5 coulomb is coming from here. So what is the net charge on this body? Net charge means the total charge. Two coulomb plus 3 coulombs plus 5 coulomb. In total we have 10 coulomb of charge on this body. Okay. What if one more charge is coming from here, which is minus 2 coulomb? So what will be the net charge in that case? In such a case, the net charge will become 2 coulomb from here, 3 coulomb from here, 5 coulomb from here, and minus 2 coulomb from here. The second point in this property says that each being taken with its proper sign. So minus 2 coulomb. So when we sum up all these things together, then we got 8 coulombs of charge. So 8 coulomb is the net charge on this body. Okay, this is a body. So this is what exactly this property says, additivity of charges. Let's discuss about the fourth property of electric charge, which is the conservation of electric charge. What does this property say? This property says that electric charge can neither be created nor be destroyed. Let's understand this property, or you can say this point, with the help of an example. Okay, let's take an example over here. Let's say we have a surface over here and we tied up one string with this surface, and again we suspend one substance with this string which is made up of, you can say, rubber. And we have another body over here, or you can say another substance which is made up of glass. It is made up of glass. So what will happen when we try to rub both these substances with each other? When rub with each other, one of the body, which is rubber, which is electron deficient, will try to gain electron, okay, and thus become negatively charged. Whereas the body glass, which is made up of glass, is having excess of electrons, and thus it will remove, or you can say donate, the electrons to the electron deficient body. So there is a movement of electron take place when we rub these two bodies. So what we exactly observe in this example, or in this case, we have observed that charge is always transferred from one body to another body. Charge is always transferred, transfer from one body to another one, or another body, you can say. So in this whole process, there is no creation or destroying of any charge over here. There is just the transfer of charge. And what does this point exactly says? That electric charge can neither be created nor be destroyed. It's always transfer. Now we are going to discuss about the fifth property of electric charge, which is the quantization of charge. So before explaining this property, let's understand what this property says about charge. It says that every charge is an integral multiple of certain smallest amount of charge, okay, that exists in nature, and this whole property of charge is known to be as quantization of charge, and you can write it as Q is equal to plus minus NE. You can represent this property like this, plus minus NE, where here N could be anything. It could be 1, 2, 3, 4 up till N. It could be any number. N could be any number. So this property says that electric charge is an integral multiple of certain smallest amount of charge. So in our nature, E is known to be as the very smallest amount of charge. Its value is 1.6 into 10 raised to the power minus 19 coulomb. You can imagine how small this charge is. It always transfer, or you can say it's the integral multiple of certain smallest number of charge. There is a multiple of N and E. Okay, so you can write it as Q equal to 1E, 2E, 3E up till NE. Okay, it always transfer as an integral multiple. You can't transfer the charge like 1 by 2E, 1 by 3E, and so on. You can't transfer the charge in a form of a rational number or any other thing. This is wrong. It always transfer in definite amount, or you can say charge always be transferred in certain smallest amount, and that amount should be some definite amount, not the rational amount like this one. So the charge in our nature always be transferred in definite amount, or you can say it in a form of 1E, 2E, 3E and so on. Okay, that what exactly this property says about charge.